we are asked to solve the equation. So we're just going to solve away. We're trying to get x by itself. That's what solve usually means, get the variable isolated. So let's go ahead and add 3 to both sides. That'll give me the square root of x minus 2 is equal to 7. Now we'll go ahead and square both sides to eliminate the square root. So if I square the left, I'm squaring the whole side here. And I've also got to square the right. When I square the left side, the square root and the square are inverse functions, so they undo each other. I just get x minus 2. The right side, 7 squared, is 49. Now if I add 2 to both sides to isolate x, I get x equals 49 plus 2 is 51. I need to check this answer. I'm going to plug it in here mentally. 51 minus 2 is 49. The square root of that is 7, and 7 minus 3 is 4. That does check, so this answer has to be right. It can't be wrong, and that's number 1. 2, we have x plus 10 raised to the 2/5 power equals 4. I need to get rid of that 2/5 power, so I'm going to raise both sides to the reciprocal power, or 5/2. So I'm raising the right side to the 5/2. I have to be careful with this because what did I just do right here with the half on the power? I square root it. And when you square root, you got to make sure you get the positive and the negative on this side. And that's probably what everybody always forgets, that dang positive and negative when you square root both sides. The left side, 2/5 power raised to the 5/2 power, that just multiplies to 1, so that just gives me x plus 10. That's nice. X plus 10 equals, I've got positive or negative 4 to the 5/2. Well, if I take 4 to the 5/2, I'm going to be doing the square root of 4, which is 2, and then take that to the 5th power, which I believe is 32. If I subtract 10 from both sides, I get x equals negative 10 plus or minus 32. That would be x equals negative 10 plus 32 is 22, or negative 10 minus 32 is negative 42. I need to check both of these and see if they work. I'm going to plug the 22 in first. 22 plus 10 is 32. The 5th root of that is 2. Squared is 4, so the 22 checks. We'll keep it. The negative 42, if I plug it in, negative 42 plus 10 is negative 32. The 5th root of that is negative 2. Squared is also 4. So both answers check. We got to keep them both. That is number 2. On number 3, I want to get rid of the radical, so I'm going to square both sides here. The left side, if I square 2x, I should get 4x squared equals the right side. If I square a square root, I should just get what's inside, so I get 6 minus 2x. This becomes 4x squared plus 2x minus 6 equals 0 if I get everything on one side. So what I did here was I subtracted 6 from both sides, and I also added 2x to both sides. None of that combines with the 4x squared, so I'll have a 4x squared plus a 2x minus 6 on the left and a 0 on the right. I see that 4, 2, and 6 have a common factor of 2, so I can divide everything out, everything by 2, and I get 2x squared plus 1x minus 3 equals 0. I'm just going to see if I can factor this with a little trial and effort here. The only way to get a 2x squared is to use a 2x and a 1x. The only way to get a 3 is to use a 1 and a 3. If I put the 3 here, it's going to give me a 6 on the outside product, which is going to be too big. So I'm going to put the 3 here and the 1 there. The signs are different. They have to be different to get a minus 3, a negative 3. A positive times a positive is not going to be negative, and a negative times a negative is not going to be negative. One of these is positive and one's negative. But I have to make sure it works out so that that middle thing comes out to positive 1. It's going to put the positive here and the negative there. If I check this, if I FOIL it back out, I get the 2x squared. I get 2x, a negative 2x plus 3x, that's 1x, that's good, and 3 times negative 1 is negative 3, that's good. So that does factor correctly. So x would either equal negative 3/2 or positive 1. I need to check both of these back in the original problem to see if they work. So plugging in the 1, let's do the 1 first because it's easier. 2 times 1 is 2, so this side would be 2. The other side would be 6 minus 2 times 1, or 6 minus 2 is 4. The square root of 4 is also 2. 2 equals 2 checks, so we're going to keep the 1. If I put in the negative 3/2, 2 times negative 3/2 is negative 3, and that's equaling a square root. That's impossible. A negative number can never equal a square root because square roots always come out positive, so the negative 3/2 will never work. We'll just reject it and only keep the 1. So for number 3, x only equals 1. That's the only one that checks, and that's number 3. Number 4 is an easy problem in disguise. Notice how both sides are being raised to the 1/5 power. If we just undo that on both sides, raise both sides to the 5th power, or 5/1, it's going to make those powers basically go away because they'll be to the 1 power. So I'll get negative 8x minus 10 equals 5 minus 4x. If I add 8x to both sides, the result there is negative 10 equals 5 plus 4x. If I subtract the 5 from both sides, I get negative 15 equals 4x. And divide by 4x equals negative 15 fourths. That's the same as negative 3.75, or negative 3 3/4. So x is negative 15 fourths. If we plug that in, that'll also check. Any questions on number 4? Or 1, 2, and 3? Composite functions, number 5, f of x is negative 2x minus 7. G of x is 5x minus 3. All they want us to do is find f of x plus g of x. Well, f of x plus g of x is just adding these two things together. So I've got a negative 2x minus 7 plus a 5x minus 3. I'll just combine like terms. Negative 2x plus 5x is 3x. And negative 7 minus negative 3 is negative 10. So f of x plus g of x is just 3x minus 10. That's number 5. Number 6, we're asked to find f of g of negative 1. I like this notation better, f of g of negative 1. This tells me to go find g of negative 1. This does too. It says go find g of negative 1 first. So I'm going to take negative 1. I'm going to put it into the g function where the x is. So I've got negative 4 times negative 1, which is 4, minus 3, which is 1. So now that's the same. Since g of negative 1 is 1, it's the same as finding f of 1. 1 and g of negative 1 are the same. F of 1 means go find the f function and put 1 into the x value. Negative 2 times 1 is negative 2, minus 7 more is negative, or excuse me, minus 5 more is negative 7. So f of g of negative 1 is negative 7, and we're done with that, number 6. Number 7, we're asked to find the inverse of the function y equals 2x squared minus 7. To find an inverse, our first step, as we learned, is to interchange x and y, leave everything else exactly where it is. So the x goes where the y goes where the x is, and every other thing stays put. And now we just have to get this y by itself again. If we can get y by itself, we've got an inverse function. So to get y by itself, I'm going to add 7 to both sides. So x plus 7 equals 2y squared. I'm going to divide by 2 next. So y squared is equal to x plus 7 all divided by 2. And then I'm going to square root both sides. What do I have to remember to do when I square root both sides? Plus and minus. So there's that plus and minus that comes up again like it does on number 2. So y will equal the positive or negative square root of x plus 7 all divided by 2. And we're just going to leave it in this irrational denominator form. We're not going to do any more with that. That's our inverse function. That's number 7. It's one of my favorite questions because it's easy. I don't even care what the function is. I'm doing an f of an f inverse. If I do two inverse functions back to back, f and f inverse are inverse functions, and it doesn't matter which order I do them in, I'm always going to get what I start with. I'm starting with a negative 3 here. I'm going to end with a negative 3. So f of f inverse is of negative 3 is going to be negative 3. And that's number 8. 9, we're going to graph the square root function, square root of x minus 2. To do this, we need to know what the general square root function looks like. What does the square root function look like? You have that in your head? In your mind? Anybody? What's the square root function looks like when we graph it? Yeah, it's kind of that shape. We're kind of looking for something that looks like this. This will be the graph of y equals root x without the minus 2. It just starts at 0, 0, and it kind of comes up like this. That's the graph of y equals root x. What's the minus 2 going to do to that? This minus 2 on the outside, what's that going to do to this graph? It's just going to shift it down 2. So we just need to shift down 2. So 1, 2, and then we're just going to curve up through like this graph does. So basically it looks like that. So there's basically an endpoint here at -2, and it takes off on that little curve to the right. And we're not trying to get this perfect yet. We're trying to get the general shape and, for sure, that starting point. That starting point is really important. I want you guys to make sure you get that one right. Number 10, I've got the square root of x plus 2 with the plus 2 inside the root this time. How's that going to move? It's going to go 2 to the left. So we're going to go 2 to the left, 1, 2, and then we'll just draw the shape. Kind of looks something like that. That's it. Number 11 is different because it's no longer a square root, it's a cube root. And we're shifting a left and right and up and down. So there's a lot to do on this one. So cube roots, what does that basic graph look like? If it's just y equals cube root x, what does that look like? Yeah. Y equals cube root x. Kind of comes through like this lazy S, right? Kind of looks like a lazy S. And it's going left forever, and it's going right forever. It doesn't really flatten out ever. It keeps going up a little bit as it goes to the right, keeps going down a little bit as it goes to the left. But there's a key point. I like to think of this center point right here as a key point. That's the one that moves. It's not an end point, it's the center one that we're going to key on. So where's that key point going for this graph? It's going right or left? Right 4 and up 3. So let's put our key point right 4 and up 3. 1, 2, 3, 4 and up 1, 2, 3 right here. Right 4 and up 3. And then what's the 3 out front going to do to it? It's going to stretch it vertically, right? So it's going to come through more steeper through the middle. So we're just going to try to get a sketch of this. It's going to look something like this. And so you would just connect that up. And what I'm going to look for on this is I'm going to look for is your key point in about the right spot, and do you have the basic shape right? And if you do, you're going to get credit on that. That's number 11. 12 here, we have an initial population of 220 quail. They increase at an annual rate of 23%. All we're asked to do is write an exponential function to model the quail population. If we look in question 13, it says write an exponential function y equals ab to the x. Question 13 gives us the form of equation we need for question 12. Isn't that nice of them? So we know it equals y equals ab to the x. What does a always represent in these things? You guys remember what a always represents? Starting amount. That's how much we start with. And what is b? What's supposed to go in the b part? The rate of growth or decay. Let's just call it growth rate, because it either grows or decays. Let's call it growth rate for this one at least. Okay, so what did we start with? 220 quail. How much percentage-wise do we have at the end of the year of our 220? Percentage-wise? 123%. If it grows by 23%, I have the whole 100% I started with plus 23% more. I'm ready to write an equation. My function, or I can use a y, I can use an f of x. Some of you guys used a q for quail. It doesn't matter. We need something here. Equals the amount I start with times the b value. 1.23 is the same as 123% to the x. Some of you guys said to the y because you made it a yearly population. That's fine. Just need some variable up here that's a power. Make sure that this is a power, not a multiplier, and you're good to go. So there's our function that models how many quail there are after X years. That's number 12. Number 13, they're giving us that they want an exponential function, y equals ab to the x. They say these 2 points are on the graph, 112 and 348. And we have to go find the equation. If I have time on the test, once I find this equation, I'm going to make sure both points work. Okay? I'm going to make sure they both work. So I don't know what to do, so I'm going to put, this is an x value, this is a y value. I'm going to put 1 in for x and 12 in for y and see what I can do with it. So I put 1 in for x and 12 in for y. I get 12 equals ab to the 1, which is just the same as ab. I'm going to solve that equation for a. No, I'm going to solve it for b. Now let's solve it for a. So a is equal to 12 over b. That's about all I can do with the 0.112. I can't do anything else with it. I'm stuck right there. So I'm going to pause working with that point and go start working with the other point. This is an x, that's a y. So y would be 48 when x is 3. A, b to the 3. But what is a? We just found out that a is 12 over b when we used the other point. So let's replace this a with that, and that'll get us into one variable over here. So 48 is the same as 12 over b times b cubed. Well, what does the b down here and the b cubed up here reduce to? B squared. So 48 equals 12b squared. If I divide both sides by 12, I can start to solve for b. 48 divided by 12 is 4 equals b squared. What's the square root of 4? It's either plus or minus 2, right? But for an exponential function, we can't use a negative, so b is 2. I know the b value that needs to go in here now. Once I can find the a value, I can write the equation. How am I going to find the a value? Well, I'm going to go back over here. Because this says a equals 12 divided by b. Well, if b is 2, what's a? A is 6. Now I know the whole function. Y equals a, which is 6, times b, which is 2, all to the x. Let's try it. If I put in 1, do I get 12? 6 times 2? Yeah. If I put in 3, do I get 48? 6 times 2 cubed is 6 times 8. That's 48. So it checks in both points. This has to be right. It can't be wrong. That's number 13.